So that is Prim's algorithm, Kruskal's algorithm, Dijistra's algorithm, Knapsack problem and Hoffman code. So all these except the Hoffman coding, all are your lab program. Prim is also a lab program, Kruskal is also a lab program, Dijkstra's is also a lab program and Knapsack is also a lab program. So all these four algorithms are your lab programs except the Hoffman coding technique. So now first I will consider this Prim's algorithm. So why this Prim's algorithm is used? Prim's algorithm is used for construction of the minimum spanning tree. Minimum spanning tree. Okay. So why Prim's algorithm is used? Prim's algorithm is used for the construction of the minimum spanning tree. So first, what is minimum spanning tree? Minimum spanning tree, MST. Usually we will call it as an MST. So before I will say what is a minimum spanning tree, first we should know what is a spanning tree. So what is a spanning tree? Assume that this is the graph what you are having. Something like this. What is a spanning tree? A spanning tree is a tree which will connect all the vertices of a given graph without forming any of the cycle. So that is like this. So what is a spanning tree? A spanning tree is nothing but a tree which will connect all the given vertices of a given graph, which will connect all the vertices of a given graph such that no cycles will be formed in that. Or one more definition I can say, it is an acyclic connected graph of a given graph. It is an acyclic connected graph of a given connected graph. Okay, that is there is no cycle. Acyclic means there is no cycles such that all the vertices will be considered. So that is a spanning tree. So spanning tree is nothing but an acyclic connected graph of a given graph which will consider all the vertices of a given graph. That is called as a spanning tree. And obviously what is a minimum spanning tree? Suppose if the weights are here. Something like this. So what are the possible spanning tree I can construct for this one? So it is 3, 4 for this one. This is 8. This is 1. This is one spanning tree. One more spanning tree I can construct for the same graph as this one. Cost is this. One more can form like this. One is like this. That's it. I think these are the two spanning tree what we can get for a given graph. Among this, whichever is minimum. 8 plus 1, 9, 9, 12. This is 12. And this is 8. So this is called as a minimum spanning tree. This is called as a minimum spanning tree. Okay. So got it. What is a spanning tree? A spanning tree is nothing but a tree which will connect all the vertices of a given graph without forming a cycle. So for a given graph you can have an n number of the spanning tree. N number of spanning tree you can have for a given graph. Among those spanning tree, whichever is a minimum, that is called as a minimum spanning tree. That is called as a minimum spanning tree. Suppose that if the graph is like this. Like this. With one edge here. Then I can construct the, this is one spanning tree. This is one more spanning tree. You can get. Okay. Then you can get this as one more spanning tree. Like this, like this, like this. These are the three spanning tree. We can get it for this. Whichever is a minimum, that is called as an minimum spanning tree. Whichever is a minimum, that is called as a minimum spanning tree. So that is about a minimum spanning tree. Now we will see how this Prim's algorithm can be used for construction of a minimum spanning tree. So where this minimum spanning trees will be used is usually it will be used in the communication networks in order to find out the minimum route or the path from the one node to another node, one IP address to another IP address. Usually these minimum spanning tree concepts can be used. Now we will see how this Prim's algorithm will be used in order to construct the minimum spanning tree. So initially I will not explain you the algorithm, because if I will explain it also you will not get anything. So first I will solve the problem and then I will explain the algorithm. Assume that some graph I am having like this. Okay. So how Prim's algorithm works for construction of a minimum spanning tree. So I can start with any of the arbitrary vertex. I'll start with any of the arbitrary vertex. Now from this particular vertex I'll identify the nearest vertex which is not yet selected, which is not yet visited. So first I will select this vertex, make it as a visited vertex. Now you select the closest vertex to the vertex 1 which is not yet visited. Which are the vertices that can be reached from this particular vertex? 4, 3 and 2. What are the cost? 1, 4 and 8. So which is the closest vertex? 2 is the closest vertex with the least cost. So now select this particular vertex. Getting my point? So initially any arbitrary vertex I will consider. Now I will identify the vertex which is closest to this vertex which is not yet visited. So that is the vertex to select that one with a cost of 1. Now consider both of these vertices. Identify the vertices which are either closest to vertex 1 or closest to the vertex 2 which are unvisited. Now add that vertex to this. Okay. So now I will consider from 1, 4 and 3. 2 is already visited. From 1, 4 and 3 with the cost 4 and 8. And from 2, 3 is there again with the cost of 4. So now what are the edges we are having? 8, 4, 4. 8, 4 is from 1. 4 is from 2. Okay. None of the other vertices can be visited. So among this 8, 4, 4, I have to choose the closest vertex or a minimum edge I need to select. So 4 and 4 both are same, but when I am implementing this particular algorithm, so what is the input I am considering? What is the input for this particular algorithm? Obviously it is a matrix. Like 1, 2, 3, 4, 1, 2, 3, 4 all will be having. So whenever I will be traversing, I will traverse from this, like this. Correct. So which is the one we are going to visit first? 1, 3 or a 2, 3? 1, 3 we are going to visit. First we are visiting 1, 3, not the 2, 3. First we are visiting 1, 3, not 2, 3. Therefore, the next edge that will be considered is 1 to 3. 1 to 3 with a cost of 4. Now, again from all these 3 vertices, 1, 2, 3, you identify the closest vertex. From 1 I can reach 4. These 2 are already visited. From 2 I can reach only 3, which is also already visited. And from 3 I can visit 5. So now the choice is between this edge and this edge. 8 and 3. Which is the minimum? 3 is the minimum. So the next vertex what we are selecting here is the 5 with a cost of 3. Now you consider all these 4 vertices, then identify which is at closest vertex. So now from 1 it is 4, which is unvisited vertex. From 2 all are unvisited. From 3 already 5 is visited. Now from 5 6 with a cost of 2. Now there is a choice between the 8 and 2. Which is the minimum among 8 and 2? 2 is the minimum. It is 5 to 6. 5 to 6 with a cost of 2. Now consider all these vertices. Identify the closest vertex which is not yet visited, okay, with the minimum edge. So 4 is only the remaining vertex which is not yet visited, but it has to be considered from 1 or from 6. It should be from 6, not from 1. Therefore, the next vertex we are selecting is the 4 from 6. So this is the minimum spanning tree that will be constructed by using a Prim's algorithm. So how this Prim's algorithm will works? The Prim's algorithm, in the each iteration, it will construct the partial tree, partial subtree, or you can say that it will construct a subtree in the each of the iterations. So initially the subtree will start with a arbitrary vertex, then it will identify which is the closest vertex to that one, then that particular vertex will be added to construct the next subtree. Next, among these two vertices, we will identify which is the closest vertex, then that vertex will be added to that particular subtree to form one more subtree. Then we have added 5 to form one more subtree, then 6 to form one more subtree, then 4 to construct the final minimum spanning tree. So in the each iteration we are constructing the subtree until unless we will get a final minimum spanning tree. So while constructing each of the subtree, we will be identifying the closest vertex and add that vertex to that particular subtree what we have constructed. That means in the Prim's algorithm, each iteration the vertex will be added to the partially constructed subtree. Got it? Each iteration the vertex will be added to the partially constructed subtree.